Hi, in this short tutorial I will review how to conduct one sample variance testing. On the screen you should be able to see the question. So Jack believes that the bakeries are not properly filling the donuts with the cream, and in order to conduct statistical testing, Jack samples the donuts, and the sampling reveals that standard deviation is S equals 0.11 cups. And Jack wants to test the H0 hypothesis, whether the population variance is 0.04 square versus the alternative that the population variance is not 0.04 square, and Jack wants to conduct this testing at the 95% level of significance. Let's see how to approach this question. Okay, so in order to complete the testing, we need to make two steps. The step one is to conduct and to find out the test statistic, which is the ratio of n-1 times S square, where S square is the sample's variance and sigma square is the population variance under H0 hypothesis. So just utilizing the first sampling data, which gives us the value of S square, which in this example is 0.11 squared. Degree of freedom is 23 because we observe 24 donuts and the respective fillings. And the sampling and the population variance under H0 hypothesis is 0.04 square. If we use this test statistic, we get that the ratio or the test statistic is 0.173. So that's the test statistic. Now, in order to find out whether this test statistic is whether it falls in the shaded or the white region, we need to find out two critical values because we are dealing with the two-sided test, and this test is two-sided because under alternative the variance is not equal to the certain number. So those critical values can be found using Excel, and in this example those critical values are 11.69 and 38.08. Let's see that graphically, okay, those numbers. Okay, here on the screen you should be able to see the critical values and the value of the statistic, and the shaded region are on the left hand side 2.5% and on the right hand side 2.5%, so that overall shaded region is 5% and the white region, which is in the middle, is 95%, because we are conducting this testing at 95% confidence. So we observe that our test statistic falls in the shaded region, so that in some sense the test statistic, assuming H0 is correct, is extreme. So it falls in the right hand side shaded region. So that's why we conclude that we have enough evidence to reject the H0 hypothesis. The video, and let's try to answer this question. Okay, now let's try to solve this problem together. So we have a post office manager who does not want waiting in the line to be too much dispersed, waiting time. So the manager samples 25 customers and observes that the waiting time for customers have the sample standard deviation of 3.5 minutes, and the manager wants to test H0 hypothesis, whether population variance exceeds 7.2, a sample deviation exceeds 7.2, or test the alternative, which is under which population standard deviation is less than 7.2 minutes. and the manager wants to conduct this at 95% confidence, so that he is not willing to tolerate type 1 error above 5%. Okay, now as before, we have to make 2 steps. Step 1, does calculate the test statistic, which as before is the ratio of 2 quantities. So we have the n-1 times s squared, which is where n is sample size, which in this example is 25. So we have n-1 being 24. A sample as a standard deviation is 3.5, and we plug those 2 numbers. In the denominator, we have the population standard deviation being 7.2 under H0 hypothesis. So we get the test statistic being 5.67. Now this is one-sided test, and the rejection region is alternative. Under alternative, sigma must be smaller than 7.2. So that's why our graph has the following form. So we need to shade on the left hand side. So this is left-sided test. Here we have 13.85, and this area is shaded area here is again 5%. So this is 5%, and next we need to see where our test statistic falls. So test statistic is 5.67, which falls within shaded area. That's why we conclude from this procedure that we can reject H0 hypothesis, because the test statistic is extremely low, assuming that H0 hypothesis is correct. And we are doing this decision so that the type 1 error is below 5%. I think that concludes our discussion about one sample variance testing. Thank you very much for your attention.